Hello, Afton. How's everybody doing today? So now we're going to be talking about sector area. Last time we were talking about arc length, so we're talking specifically about a length. Now we're back in the realm of area. So what is sector area? It is the area of a circle under a given arc. So right here, okay, we talked about area. That was what last chapter. We're talking about all those different areas and things like that. So now when I'm looking at this whole circle, I can find the area of that whole circle. But really, if I just wanted the sector area of AB, I'm talking about wanting this right here. So I always think about sector area as if I have a whole pie and I cut myself out some of that pie and I'm like, I'm taking this for me. Like, how much did I take? That's what we're trying to find here. If I took that big, and that is like a Mr. Keith sized piece of pie right here. If I'm eating a pie, I'm eating almost half the pie. So basically, how much did I take from that pie right there? So that's what, the way I always think about it, the way I want to figure it out and everything else. I don't know why that's so low. So if I want to find the sector area, if I want to figure out what the sector area is of this right here, again, it's very similar. I need to figure out the percentage of this. So to figure out that percentage, I'm going to take the measure of arc AB and divide that by 360. So that tells me how much of the circle I'm looking at times, and then again, if I want that sector area, I'm just going to multiply by the area formula. Percentage times area. Again, I know this looks very similar to the formula that we did yesterday. The main thing, like I said, is that now we're talking about area. So make sure, because the problems are even going to look similar on tonight's homework. Make sure that you're always reading those directions. You know, the things that tell you what to do. They're kind of a big deal. So make sure that you are always reading those directions to know, hey, I'm being asked to find sector area. I need to use the sector area formula. Now, what I said last time still holds true when it comes to reducing those. Make sure 45, 30, and then 15 as a fallback, if you can't divide by the other guys, are always good places to start. Now, again, those are just good numbers to start with. I'm not saying there can't be other numbers. So if I want to find the sector area of CD, we can see, hey, I already highlighted it for us. We got that right there. I know that this measurement right here is 135. So if that measurement right there is 135, then I can go ahead and, I just realized I'm going to have to add a problem to this. Sorry. So if it's 135, I'll set this up. I'll have 135 over 360 times pi 4 squared. So I can reduce this fraction. I can divide top and bottom by 45. That goes in 3 times. 360 divided by 45 is 8. And then times 4 squared is 16 pi. Now again, just times the top, divide by the bottom. 3 times 16 is 48 pi over 8. Well, look, 8 happens to go straight into 48, so I just know this is going to be 6 pi. Now, there is one additional thing that we can do here. And that one additional thing, or not one that we can do here, that we have to do here, and that is our unit. Well, now we're talking about area. So I had 4 centimeters over there. That means this is going to be centimeters squared, or square centimeters. Centimeters squared centimeters, same thing. Our unit on these problems is going to be a square unit because we are talking about area. Again, much like I said before, when you're typing this on Canvas, you don't have to type the unit, but I always want to talk about the unit because it is important. We want to make sure that we always know what unit we're talking about here. Once we set it up, again, the steps look similar to what we did yesterday. So that's why I don't think this video is going to be too terribly long, because if we understand what we did yesterday, then yeah, we're just kind of doing the steps similarly. Our formula is the only thing that's really different. All right, so sector area of ED, again, this is going to kind of be what your problems look like. They're not going to have that all shaded in there. So we just need to recognize, oh, it's ED. So they're talking about what's in right here from E to D shortest path. But then once we have that, again, set it up. 60 over 360 times, and then right here we have pi 9 squared. Now, conveniently, I was like, we can go ahead and that reduces. I can divide top and bottom by 60. Hopefully you can see that, cancel out the zeros. And then 6 over 360, I get 1/6 times, and then this is going to be 81 pi. So that's going to give me 81 pi over, 81 pi over 6. Now they're not even, so I know I can't divide by 2, but I know I can divide a 6 by 3, and I can divide an 81 by 3. This is going to end up being 27 pi over 2. And then my unit, feet squared. Now, just because with these fractions, I always like to remind us when we're typing these in on Canvas. Again, 27 pi, abbreviated pi, and then again, that slash, and then 2. That's how we would simply type that into Canvas. Is it difficult? I don't think so either. All right, now we have the sector area of PQR. All right, so we got P, Q, and R. So we're talking about this right here, this arc right here. So then I want that right there. Now, there's a few ways that you can think about this. Either one, I can say, okay, well, I need the arc measure. Well, if this is a diameter, what would that measurement be? Well, that would be 180. So I can say 180 divided by 360 times, and then pi. What's my radius here? Got to be careful. They gave me the diameter of 40. I need the radius of 20 squared. Now you might say, well, what was the other way? Well, if this is if that's half the circle, this reduces to 1/2. Again, if you can think about that while you're doing it, then great. I was like, I think identifying and thinking about that, oh, that's a 1/2. Yeah, it's half the circle. So it's 1/2. That's just as good as knowing the formula, in my opinion. Times 20 squared is 400 pi. And then again, right here, I know I could write it this way and say 400 pi over 2, or I can say, okay, what's half of 400? Oh, well, that's 200. And then again, my unit, inches squared. Man, there was another problem I was thinking about giving you. I'm not gonna worry about it. I'll just give it. But again, that's the big idea. That's if we know the formula, it's just a matter of looking at the picture, pulling out what we need, plugging it in, and then just simplifying, doing the math. I don't think there's anything that's, again, overly challenging here. That's not to say that there aren't going to be some difficult things. There are going to be some fractions that might be hard to reduce and stuff like that. That's not to discredit the rest of these problems. It's just to say, hey, if we can do these things, then all of these problems are able to be done. Mistakes happen. We all reduce wrong. We all write down the wrong number from time to time. Those things happen. I don't care. Again, if you miss one or two problems, it's not the end of the world. But if you miss a lot of problems, that tells me, hey, you're probably not understanding this. And again, since this is an easy topic to put onto the final, you probably want to make sure that you know how to do these things. So I'm wearing a hat. It's a big circle hat. Sorry. So, again, if you do have questions, always come to the Google Meet, send me an email, let me know that you need help so that way I can help you. On that note, I will bid you adieu. Until next time, stay safe out there, Afton.